Dear students, now we are going to discuss about Stokes' theorem and its proof applications. Stokes' theorem relates line integral and surface integral. So here it relates line and surface integral. The definition of Stokes' theorem is given like this. The definition of Stokes' theorem is the line integral of a vector around a closed path is equal to the surface integral of the normal component of its curl over any closed surface. So here it is going to relate two things. One is line integral, another one is surface integral. Okay, so surface integral of the curl of the vector over any closed surface. So this is the general relationship. So Stokes' theorem can be expressed like this: line integral of any vector. So here we can consider h dot dl, that is equal to surface integral of the curl of the vector. Surface integral of the curl of that vector. So this is what the expression for this Stokes theorem. Now we are going to prove this statement. How can we relate that line integral of a vector around a closed path is equal to the surface integral of this curl? Okay. In order to prove this Stokes theorem, first we are going to consider a closed loop. So consider this is a closed loop with a length L. This is a closed path with the overall length as L. It is simply a closed path. Okay. So a closed path can create a surface, open surface here. So here it is the surface is also closed by this line. Okay. So this closed path can create a closed surface. Okay, this is a surface. Now we are going to subdivide this surface into different cells like this. We have subdivided the surface S into k number of cells. Large number of cells we have subdivided. This arrow mark defines the flow of charges. Okay, in which direction it is getting flown. Okay, so here we have to consider one loop, the kth loop. Okay, so consider this as the kth loop. So I can take this loop alone outside. So we have subdivided the total surface into different cells. Okay, so number of cells. I have taken this particular any one of the cells outside like this. So in this one, this is the closed loop. Okay, length of this closed loop is nothing but Lk. So L is the length for the kth loop. Likewise, that surface is a del Sk. Okay, it is a smaller surface when compared to that overall surface. So del Sk. So here that I told you, right, arrow mark defines what? The flow of charges. Okay, so here the charges are flowing in this direction. So that is the meaning of this. Okay, so now I am going to place one stick over there. I am going to place one stick over there. So now what will happen means, because of the flow of the charge in this direction, it forces the stick to move in this direction. It starts moving towards this direction. Okay, at that point, due to the charges moving in this direction, so the stick further rotates like this. So the stick is continuously rotating with respect to the direction of the charges. Correct? So rotation means what? It is nothing but curl. This rotation on the surface is directly depending on the closed loop. So it is going to rotate within that loop. Okay, so within that line part. Okay, so within the closed loop. So here we are going to define. So here we can directly relate the line integral is directly proportional to the curl of the field. Okay, so because curl means what? Rotation. Okay, so that is what given like this. The circulation of a vector A around a LK, that is particular in this one. Okay, so here it is the length of the overall length of that particular cell. Okay, so in this one I can define my field is A vector. So the circulation around this path is nothing but the line integral. that overall it is continuously rotating over that line, right? So it is the line integral. So circulation around this particular path is line integral of A dot dl with that length. K is the length. So if I want to find out for the overall closed path, so I'm going to find out the circulation for the overall closed loop. So for that I can write integral over the total length A dot dl is equal to summation k, because there are n number of cells, k number of cells. So each cell is having its own rotation. We are going to add all those circulation to get that overall circulation for that closed loop N. That is what summation k integral over Lk for the particular length of each cell. Now for further simplification, I am going to multiply and divide by del Sk in this equation. So I am going to multiply and divide by del Sk. Why means we know that circulation per area, the circulation per unit area is nothing but curl. Correct. The circulation per unit area is called as curl of that field. So we can replace, this is the formula for curl. So del cross A vector. So summation k del cross A vector into del Sk. Summation over the loop means it is nothing but surface integral. Okay. So surface integral of del cross A dot this del Sk becomes ds here. So for this is for overall length. This is for the particular cell. So now we are going to consider summation of all the cells. So summation of all the cells is nothing but the overall surface, that can be represented as surface integral of del cross A dot ds. So now we have proved that line integral of A dot dl is equal to surface integral of del cross A into ds. Okay, so we have proved the Stokes theorem. So next, applications of Stokes theorem. So Stokes theorem is mainly used to convert the surface integral into that line integral and vice versa. We can convert that line integral to surface integral also. Okay, right? And also to find the line integral of some particular curve. Okay, so if I want to find out the line integral of particular curve, I can directly use this Stokes theorem. Okay, and also to determine the curl of a bounded surface. So these are the major applications of Stokes theorem.